we're going to wrap up section 5.6 by doing our evil twins, our reciprocal functions, our secant and cosecant graphs. So I'm going to just show you a quick sketch with those two to start. So here is 2 pi, here's pi, cut those in half, pi over 2, 3 pi over 2. Okay, now what I'm going to do is I'm going to start with their reciprocals. So in my black, I'm going to graph, remember secant is the reciprocal of cosine. I'm going to start with that. In a non-transformed function, cosine would have a period of 2 pi, amplitude of 1. Cosine starts high, bottoms out at pi. So if you're doing this in your notes, you should be doing this in very light pencil, this curve. Okay. And what you're going to do to turn that into secant, I'm going to switch colors. You should do that as well, or maybe just switch to like X's or something when you're graphing. You're going to create asymptotes. Remember that these are reciprocal, so any locations where these are 0, if you flip those fractions over, those will be undefined. So find the x-intercepts and draw asymptotes there. And then what you're going to do within those asymptotes is draw the curves. So I'll do those in purple. So it's almost like a mirror image. That's exactly what it is. It bounces off of that cosine curve. Now, these guys up here, I'm going to draw half of it. Don't draw this part. Technically, there's another half of the curve, but remember, we're only doing one wavelength, so that's why we're just doing that one little piece. Oh boy, I gotta delete all those individually. There we go. And then here's the one here. And again, there is more over here. We're just not drawing that. So the purple curve that I have there is the graph of y equals secant x. That is the reciprocal of cosine, okay? And if you wanted to erase the black stuff or your pencil or whatever, that's fine, but you can leave it there as long as you're neat and organized. So let's do cosecant. Okay, I added those labels on there. I don't know if you guys can hear him, but Max is sitting here purring so loud. Sorry if that's annoying. Okay, so I'm doing cosecant. I better leave myself some space. And cosecant is the reciprocal of sine. So start with your light pencil, draw the standard non-transformed sine curve, one wavelength worth. Then again, any place that you have x-intercepts, if you were to do the reciprocal of those zeros, those would become undefined. Those are where the asymptotes are located. And then go in and draw your mirror image curves. Okay, so again, got 2 full curves for the cosecant. For secant, you get like those 2 little half curves. And again, that's because of the placement or the staggering of sine and cosine. Here are my expectations in terms of this class for how you would graph these. Like I did, graph sine and cosine in pencil, draw those final secant or cosecant graphs in red or some color or some way for us to make it clear that those are transformed. Make sure you're drawing the asymptotes. You should have labels on all 5 important points, and of course anything on the vertical axis that we might need. So let's do a couple examples. Putting it all together seems to be our theme, huh? Okay, so amplitude of this graph, and again, as I'm going through this, I'm thinking about this like it is its reciprocal function, like it is a cosine graph with all of this information. So the amplitude would be 1, the period would be, we're back to 2 pi, standard period of sine and cosine, 2 pi divided by b. For this example, that's 2 pi over 2 or pi. So one wavelength fitting in pi units. There is a phase shift, c divided by b. That's pi over 2 divided by 2 or pi over 4. And it was minus, so we're going to the right. And lastly, our vertical shift, we are going 1 up. Okay, I'm going to take care of all those labels first. So pi would be the period until the phase shift. Then we'll need some more labels there. I'm going to cut that in half. That would be pi over 2. I'm going to cut those in half. That would be pi over 4 and 3 pi over 4. And eventually I'm going to the right another pi over 4. This would be 4 pi over 4, so that makes 5 pi over 4. Now I'm going to handle the vertical labels. Amplitude was 1, but we're going to also shift up 1 unit. In fact, I think I want to make that a little smaller. You'll see why. Okay, labels look good. So grab your pencil, super light pencil. I am going to graph the cosine curve with the amplitude in the period change first. Start high, bottom out at typically pi, but we had a period change. There we go. Really light pencil. Okay, that takes care of amplitude and period. Next, we would do phase shift and vertical shift. So each of these dots is going to go to the right pi over 4 units and up 1. If you can do that all at once, good for you. If you need to take a middle step here, what I would recommend is keeping your pencil, go to the right 1 and up 1, and use something different like an X or a star to plot your points so you can tell the difference. Right 1, up 1. This guy, right 1, up 1. This guy, right 1, up 1. I said right 1 tick mark, pi over 4. Light pencil. Okay, now I've done the cosine curve. Next, switch to your color or your highlighter or whatever it might be. Drop those asymptotes through what would have been the x-intercepts, okay? And then do your reflections. So this graph has asymptotes at pi over 2 and pi. And you need to be able to see that that has moved up 1 unit. Okay, let's do another one. This one is a cosecant graph. And let's go ahead and identify the changes first. The amplitude is 3, but do you notice that's negative? That means that we're going to have to flip that graph over. The period is 2 pi divided by the b value, and that b value is 1, so we're at 2 pi. Wonderful, love when there's no change. The phase shift is c divided by b, so that's pi over 2 divided by 1, so just pi over 2, it's minus, so we're going to go to the right, and there is no vertical shift. All right, so I'm going to handle my labels. 1, 1, 2, 3, 1, 2, 3. Okay, period was pi, but we do have some shifting, so, excuse me, 2 pi. Cut it in half, pi. Cut those in half, pi over 2. 3 pi over 2. I am going to shift pi over 2 to the right, so that means I need to make space for that as well. This is like 4 pi over 2, so that means this is 5 pi over 2. I'm going to my really, really light pencil. For me, that's going to be black. I need to flip a sine, reciprocal function, curve, and make it fit in 2 pi radians. And amplitude of 3. Okay, so notice I went low first. That's because of the minus, and I'm going to peak out here at 3. There, that looks pretty good. Next, I'm going to handle the phase shift. There is no vertical shift, so that's nice. So I'm just going to slide each one of those pi over 2 units to the right. I'm sticking with my pencil, and I'm just changing to the x's. Okay, next switch to your color. Drop your asymptotes through what would be your x-intercepts. They actually stayed x-intercepts here because we didn't have any vertical shifting. And then go in there within those asymptotes and draw the curve. That is a cosecant graph. So I think these are pretty neat, but you definitely have to have an understanding of sine and cosine in order to be successful here. So red curves and red asymptotes are final answers there. You'll notice I had to draw 3 asymptotes for cosecant, and we just end up having the 2 asymptotes there in 1 wavelength for secant. So, all right, that wraps up section 5.6.